All right, today we got a little bit of adding fractions practice. Remember, if you were in class, you should have a couple of good examples on how to do this on the back of your worksheet because we did those in class. In this video, I'm going to do half of the problems here. Follow along. Hopefully you'll have the idea after I do half of them because the other half will be up to you. Please make sure to show your work. Show me those common denominators. It doesn't have to look exactly the way that I'm gonna write it here in this video, especially these arrows that you might see me draw to help you follow along. You don't have to draw those, but the work should be there. If you're just writing answers, you will not get credit for those questions, okay? Might as well start with the first one, right? So step one is to carry the problem over with all the symbols and stuff you're going to need. We're going to have to rewrite this problem with common denominators on the bottoms of the fraction. We can't add eighths to thirds. So we might as well set the framework for that. I'm going to put a new fraction bar here. So that's a fraction bar that I'm going to put numbers on top and bottom of. I'm going to put a plus symbol because I know I've got a plus in this problem. And I'm going to put another fraction bar. And then after that, I'll get the answer. So it'll be equals. And it's going to equal a fraction. So I'm going to have another fraction bar. So what we have here is fraction bar plus symbol, fraction bar equals fraction bar. Okay, now step two, let's figure out the denominator that's going to go on the bottom of all those fractions. Remember, denominator means the bottom of a fraction. So in this case, the denominators we have are 8 and 3, but they are different. We want that denominator to be in common of the two fractions we're adding, so we call that a common denominator. There's a couple different ways you can determine the common denominator you want to use. Um, One way is to start with the smaller of the two denominators you're working with. So in this case, it'd be the 3, and count by your threes until you arrive at a number that is also a multiple of 8. So you would go 3, 6, 9, 12, 15, 18, 21, 24. 24 was the first number I said that was a multiple of 8, so I would go with 24. Another technique that's maybe a little bit faster, but not always the best choice when you go to actually complete the math, is to just multiply them. 3 times 8 is 24. Um, Either way, in this case, we arrive at 24, but you'll see that sometimes the first strategy gets you a little bit easier denominator to work with. But if you can't figure it out, you can always just multiply the 3 and the 8 and get 24. So I'm going to put a 24 in pink underneath the first fraction, and I'm going to put a 24 in blue underneath the second fraction. And then my answer, when I add the fractions, you don't add the denominators. That 24 is going to stay a 24 in the answer. And so I'm going to put a 24 across the at the bottom of the answer fraction too. And so now my problem's rewritten with all the pieces and numbers I need except for the numerators, the numbers on the top. Well, the idea is to write this first fraction as a fraction that is equivalent to 5/8 but in 24ths. And the way we do that is determining whatever number we multiplied or divided this 8 by to arrive at 24. We just do the same to the 5 at the top. So like this. To go from 8 to 24, I'm multiplying by 3 because 8 times 3 is 24. So I'm going to write a little times 3 in pink down here. And so then what I do is I do the same thing to that 5 on top. Oop, 5 times 3 equals 15. Boom. And now I have a equivalent fraction to 5/8, but in 24ths, 15 24ths. All right, now I do the same thing to the second fraction, the 2/3. I'm going to use blue arrows. And so I'm changing 3 into a 24 in the denominator. Well, 3 times 8 is 24. Ooh, I should have wrote that different. And so now I take this 2 on top and I have to multiply it by the same 8. If I go 3 times 8 is 24, then I have to go 2 times 8 is 16. And I've got my equivalent fraction to 2/3 in 24ths. Okay, like I said, you don't add the denominators, so it just stays 24. We do add the numerators, though, the numbers on top. 15 plus 16 is 31. Let me get my black marker. And boom, there's our answer, 31/24. You could write this as a mixed number. Like since this is over one, you could write it's an improper fraction. The number on top's bigger. So you could write it as 1 and 7/24. I don't really need you to do that though. I'm happy with the answer, 31/24. We can just leave it as that. Maybe box it. Okay, so for the rest of the four problems, I'm not going to explain quite as much. I feel like that was a really thorough explanation for that first one. For the rest of them, I'll just kind of talk as I write, but go a little faster. Okay, so I'm going to jump to, how about, let's do number 4. 1/2 plus 4/9. Okay, so I'm going to start it the same way I did before. Write the whole framework. Fraction bar plus fraction bar equals fraction bar. Now let me determine my numerator. In this case, let me just count by my twos until I get a multiple of 9. 2, 4, 6, 8, 10. Okay, I skipped over 9. 12, 14, 16, 18. That's a multiple of 9. 2 times 9 is 18. Okay, so either way, you could have multiplied by 2 times 9 or counted by your twos, whatever the case is. 18 is the first common multiple or least common multiple, we say, of 2 and 9. And so, oops. And so 18 will be our great choice for common denominator here. Okay, so I put 18s across all the denominators of my new rewritten problem, and now I just have to do the numerators. Well, on this first one, to change that 2 to an 18, I'm going 2 times 9. And that means across the top here, I have to take this 1 and go times 9, and I get 9. And then for the second fraction, I started with a 9 in my denominator. In order to get that 18, I'm going times 2. And so I take the 4 on top, and I go times 2 with it, and that's going to be 8. And so now I just do 9 plus 8 is 17/18. All right, 2 down. Let's go straight to the one below. I'm going to do 3/8 plus 5/7. And I'm going to move my work down a little bit because my work takes up a little bit more space than yours probably does because I'm drawing all these arrows. If you're not drawing the arrows, then you can fit your work in a little bit neater. Okay, so I'm going to kind of shift down a little bit. It's going to be fraction bar plus fraction bar equals fraction bar. And then my original denominators are an 8 and a 7. Now this time, it might be kind of a pain to like count by 7s until I find that multiple of 8. And so I'm just going to multiply them this time. I'm just going to go 7 times 8, which is 56, and just use 56 as my denominator. There might have been a better choice, but this time I'm just going to go the multiplication route. And so now I got 56 as all my denominators across the board, and I just got to figure out what my numerators are going to be. Well, 8 times 7 is 56. So on the top, I'm going to go 3 times 7 is 21. And then for the second fraction, do a little squiggly arrow here. 7 times 8 is 56. And so on the top, I'm going to do a little squiggly arrow here. Whoop. 5 times 8 is 40. And so all we need to do now is just 21 plus 40. And we get 61/56. And again, you could change that to 1 and 5/56, but I don't need that from you. Just leave it as 61/56, please. All right, let's do 2 more. I want to jump down to number 7. Let's do 7. And so I'm going to start it the same way. Fraction bar plus fraction bar equals fraction bar. Okay, step 2. Now let me see if I can move my paper up a little bit. Step 2, let's see if we can figure out a denominator. Again, I could count by my 7s until I get a multiple of 9. I I don't think there's going to be a multiple of 9 until we get to the seventh multiple, 7 times 9, which is 63. So I'm just going to jump straight to 63. Okay, the whole idea of the common denominator is to just find a number that is a multiple of 9 and a multiple of 7. Sometimes you can find that by counting multiples, and sometimes you just multiply the numbers, and then you're guaranteed to get a number that's a multiple of both. Oops, I forgot to do my colors. Usually I do pink, blue, and then black, but whatever. Hopefully you don't need that at this point. I'll revert back to the colors for this part. So for the first fraction, to change that 9 to a 63, we need to go times 7. And so on top, we take this 2 and we multiply it by 7. 2 times 7 is 14. So we get 14/63. And then on the bottom, we're taking this 7 shoop, and multiplying it by 9 to get that 63. So on top, we take this 3 and we multiply it by 9. 3 times 9 is 27. Now all we got to do is add 14 and 27, which I believe is 41, and we get 41/63. Okay, I'm going to do one more for you, and I'm specifically going to pick the last one because the number 10 and number 8 have something in common that I'd like you to see. And so I'll do number 10, and then you can do something similar on number 8 when you go and do it. On both number 8 and number 10, you should notice that the bigger denominator is a multiple of the smaller one. Like 6 is a multiple of 3 because 3, 6. And in number 8, 8 is a multiple of 2 because 2, 4, 6, 8. When that happens, just use the bigger of the two denominators as your common denominator, and it saves you like half the work because you only have to change the fraction with the smaller denominator. This is where the counting by multiples strategy comes in really handy. Whereas we just multiplied the denominators on a couple of previous questions. On this one, you could multiply 6 times 3 and use 18 as your common denominator. Be a perfectly fine way of doing it. You get the right answer, but maybe it's a little bit more efficient and you get a more simplified answer by noticing that 6 is a multiple of 3. And so I'm going to go fraction bar, plus symbol, fraction bar, equals symbol, fraction bar. And then since I already noticed that 6 is a multiple of 3, 6 is the best choice for my common denominator. 6, 6, and a third one. And then now the second fraction here in the problem started with a 6 as its denominator. And I'm going to rewrite it as another fraction that still has a 6 in its denominator. So I don't have to change anything. Nothing's changing for that fraction. And so this 5, 6 can still be 5, 6. That's what's nice about it. Like half the work's like gone, right? The only thing I have to do is make an equivalent fraction for this first one that used to be 2/3, but I'm doing 3 times 2 equals 6 on the bottom. So on the top, I will go 2 times 2 equals 4. Now I do 4 plus 5 equals 9. I get 9, 6. And you could super simplify this one. You could simplify it to 1 and 3, 6. You could simplify it to 1.5. You could simplify it to just 3/2. There's all sorts of ways you could write this answer. The simplifying part isn't really our focus right now, though. And so even if you just left your answer as 9, 6, I would be happy with that. All right.